So, Taming the Beast. I remember when I saw that my talk was accepted, I realized, like, wow, I really picked a clickbaity title for it. We're going to be talking a bit about how we manage schema migrations, particularly at Intercom. We've got a big engineering team. But who am I? You've heard that I've spoken 3 times at Rails World, but I'm an engineer on Team Data Stores at Intercom. I'm kind of directly responsible for databases, caching, things like that, but the team also owns other stuff, including our Ruby on Rails platform, which is surprising to some people. We're responsible for holding and raising the bar for productivity at the company, so anything that helps make our engineers more effective is kind of part of our wheelhouse. And as we already said, it's my 3rd time being here. Quick disclaimer. Lots of what we're going to talk about kind of is MySQL specific. Intercom's a MySQL shop, but the concept should broaden out to other database technology. How do we think about productivity? This is kind of important because for us, making schema migration tooling really good is an important part of making our app available and keeping everything safe, but it's actually a really important productivity tool as well. Rails has great resources for learning. The Foundation's been doing some great work there. But things that work when you're small don't necessarily work at scale. When you're running a big database like Intercom, we have around 300 terabytes of relational data, multiple 10 plus 50 plus billion row tables. You need to know some different things and consider some different stuff when you're working at that scale. But we should still try and make sure that engineers working at Intercom can Google something, read the docs, look up the Rails guides, and get the right start. The worst thing would be if you start as a new hire in Intercom, you've worked on Rails before, you know Rails, and then you try and use Rails idioms in Intercom, and it doesn't work. So that's what we're trying to avoid. And that's kind of only getting more important now that LLMs are doing more and more of the driving, because LLMs are trained on what's out there on the public internet. If we had some specific processes you had to follow, that would be even harder. We'd be polluting the context window trying to tell them how to run a migration. So that's the framing we're coming at it from. But maybe you've just started a new Rails app. You probably don't have a ton of data. You maybe have no real data in your database, and you probably don't need a zero downtime deployment. So you can get away with a lot. And let me say this right now: if that's you, if this fits you, you don't need to worry about this stuff. If I didn't have to worry about this stuff, I wouldn't worry about it either. Early days, it's way more important to focus on speed of iteration. Just try stuff. We're going to really quickly scale up to talking about things that apply to the scale that Intercom is at, and that might be interesting to think about, but do the minimum amount of process that will work for you and that will keep you fast. Because scale is a nice problem to have. Issues are going to happen as you grow. That's just kind of inevitable. The first time you learn that your core data model is too large to migrate safely will be when you try and run a migration and everything goes down. And the first time you learn that your customers are sensitive to the downtime being caused by your database operations will be when you have a bunch of angry customers beating down your door because you just ran a migration. That's life. That's fine. That's good problems. But the important thing is to learn from it and make sure that you don't keep making those same mistakes. You don't want to have to explain to customers, oh yeah, the 4th outage this week is because we keep doing the same thing and it keeps going wrong the same way. Remember the kind of saying from aviation safety and other safety critical industries, checklists get written in blood. So to that point, we're gonna talk about checklists. Because checklists, runbooks, whatever you want to call them, as soon as you're big enough to start needing some kind of process, this is probably where you're going to start. This is the natural first step. So checklists, they document the edge cases you're aware of. They tell you the things you need to do. And they're a great tool for new people, onboarding, understanding the operational parameters of your app, where the sharp edges are. But you want to keep them small. You don't want to clutter them up. I have like an absolutely abiding hatred for what I call a choose-your-own-adventure checklist, where every item says like, oh, in this situation, you have to keep this in mind, but in that situation, you don't have to do it. Skip on to the next thing, like turn to page 4. That stuff just drives me absolutely crazy. Like every checklist item is a liability. So you don't want to be putting things in your process unless you've seen it hurt you. You want to keep those like sharp tools like DHH was talking about earlier. You want to keep them. Like that's an important part of productivity. You don't want to like try and shave off every sharp edge, like go too far with guardrails. But you also don't want to keep repeating the mistakes like we talked about. So if you have your checklist, you know what your operational parameters are. It's only useful if people are actually using it. And when people are like working on your app, when they're making a migration, where are they going to end up? They're going to end up in a PR. So I want to meet people where they're at. If they're opening a migration PR, they're in GitHub, they're doing PR review. That's where we should put it. When we first created a checklist for migrations in Intercom years ago, it went into our internal wiki. I don't know if anyone ever really read it. Ended up in Notion. People didn't read it there either. We have Coda now. It might be in there. I can't find it. So we want to post it onto their PRs. And to that point, you can scan this QR code. It's a GitHub action. It's what we use at Intercom to post the checklist. I've bundled in a stripped-down version of our checklist. It's basically everything we have in there, but I left out the really gnarly stuff around like how our ETL pipeline works. You don't have to run our ETL pipeline. You don't need to worry about how it works. But it has some like common sense stuff. I don't necessarily love everything about it, but it is a good start. I'll leave that up for a second more. But we can take a look at what's in there. I had to shrink this down to fit it on the page. So don't worry, we're not going to go through everything line by line. This is the checklist that we'll post. The kind of maybe the more interesting things in yellow, but that means it will be bold. Don't merge the PR if your application changes before you complete all the steps in the checklist. That's an important part of like zero downtime, because when the deployment happens, the migration may not have run yet, so you don't want the code that relies on it out there in production. Fine. Another fun one, if you run Postgres, you don't notice pane. If you're making more than one change, use change table, set bulk true, because MySQL does not have transactional DDL. So anytime you run a statement, that just happens. And if your migration fails in the middle, then it will be in an inconsistent state. One thing you'll notice if you do read through it, or if you have opened up the GitHub action that I linked before, not everything in here is that kind of operational scar tissue. Some of it is purely educational. Like, your PR must contain the schema RB file updated. If your migration file has an older timestamp, leave the one in the schema file untouched. You can't make your migration go back in time. That's not going to cause an outage, but it kind of handles things that new people to Rails might be surprised by. So, great. We have a checklist. Now, all of our migrations are going to be safe. The end, right? That's it. Cool. Thank you. I'll be off. No, like seriously, it's not the end. It's pretty good. Checklist pops up in the migration. Fine. It does tell you things you need to know. Great. But it's not quite enough. Like, you might be surprised to learn that even checklists are fallible. I've had new hires DM me on Slack in Intercom and ask me, what does something on the checklist mean? They tried it and it didn't work. And I go and look and realize, like, oh, that's not worked that way for 18 months. And nobody has said anything at any point, which tells me that everyone is doing a real good job reading the checklist. And like, I'm guilty of it too. I run schema migrations. I don't read the checklist. I wrote the checklist. I don't need to read it. So by the time the PR is opened, like the engineering work is finished. People have kind of switched mode a bit. And if we tell them, like, oh, you have to go back and do something differently, that's kind of annoying. It's a bit of a productivity drain. It's a useful tool in the toolbox, but it's not everything. It also doesn't do anything to handle, like, if you have a big table, running a migration might take 24 hours. And if you're doing certain operations in MySQL, that table might be locked for writes for 24 hours. That'd be a pretty bad outage to have. And the checklist, we're not going to go back. The checklist doesn't really do much to help you with that. And it also doesn't handle people just making mistakes. Like, mistakes happen in the same way that outages happen. You can't just say, like, oh, we'll just never make a mistake and everything will be fine. So we do need to go a bit deeper than this. One of the things we want to do is we want to make sure to fix issues before they happen. We should be telling engineers about risks while they're writing their migration. And that kind of, like, when I thought about it, that sounds an awful lot like linting. And we have Rubocop. So, like, let's get Rubocop on the case. We can take an example now. This is, I dug back through the annals of time in Intercom. This is migration from 2011, when the company was only like 4 or 5 people, and I think it's pretty representative of like a normal migration that you might make on a new Rails app. We're like adding columns on the messages table. We're adding some columns on the comments table. It's fine. We're doing some adds. We do the down. We do the reverse. It's all good. This is a real thing. There's nothing wrong with it particularly. I wouldn't let you merge it now, but there's nothing wrong with it particularly. Why wouldn't I let you merge it? Like I said before, we kind of touched on it in the checklist. Every line there is executing a new SQL query. On MySQL, none of those things aren't atomic, so the migration isn't atomic. You can, if you have Rubocop Rails, you can put this into your Rubocop YAML, like Rails bulk change table. Enabled, you're running on MySQL, include your migrations directory, and it will warn you that, like, oh, hey, you could bulk those things together. And that's pretty good. It will tell you, like, oh, those messages changes could have been one migration. The comments columns could have been another bulk change table. But it only warns you when operations that could be bulked, could be combined, aren't being combined. It doesn't warn you that, like, even if you combined all of the changes on the 2 tables, that would still result in 2 distinct alters, and that could still fail in the middle. So we went a bit further. I just copy and pasted the code into a gist. This is the actual cop we run in Intercom for this. It kind of does the same thing as the Rails one, but it ensures that, like, in addition to combining all of the bulkable operations, there can only be one operation left once they've all been combined. So you can't get into a situation where a migration could fail in the middle. It's a bit of an edge case. It's annoying when it happens. So that's good. That's an example of something we can do with Rubocop, something that people just don't have to worry about anymore. What else can we do? So if you were in Toronto last year, if you saw my talk from 2024, you might know how this story ends. Big int foreign keys. So we had an interesting problem in Intercom where, since I don't remember what Rails version, the ID column defaults to being a big int. It's a good change. We've hit max int many times on different tables. So the default being big int is good, but you can still sometimes end up with external references being the wrong type. We don't tend to use the references function when we're making migrations, because actually we have a lot of vertically partitioned databases where tables live in different schemas, so you can't join across them. And also in MySQL, you can't really rely on foreign key constraints if you've got a large database, so we don't do it. But then you can end up in a situation where, like, table A references another table, and that has the foreign key is a regular int, table B is a big int, and then you're going to run out of, when table B exceeds a 32-bit int, then everything breaks, because now you can't insert rows into table A anymore, getting pretty abstract. That causes us a lot of headaches. Like, you can watch the video from last year. It was a painful time. And one of the things we did afterwards is another simple custom cop. I mean, I kind of hope you don't need this one, but if you want to have a look and see how it works, go ahead. What this does is look for columns that end in _ID and doesn't let you use a small int type for them. It's a little heavy-handed, but it works for us. And I think a lot of the time with writing good rubocop rules, it's a bit like what I think of writing good regexes. You don't want to try and overfit. You just want to handle the cases that you know about. And yeah, that works pretty well. So last one. And we're going to lead with the code this time. And you'll find out why. We have another custom cop that blocks using the execute method in migrations. So you probably know that execute is the way to run raw SQL. It's fine. Like, I know a lot of people do it. We didn't have a ton of examples even before adding this cop. Now we have none. I like using those helper functions. Sometimes people like writing raw SQL. I can write raw SQL as well, but it's something we wanted to stop in Intercom. And we wanted to stop it for a better reason than just my sense of aesthetics. Because catching things in development is great. Popping up warnings in Rubocop, fine, that's pretty good. But your development database is still different to your production database. We don't pre-provision everyone's developer environment with 50 terabytes of conversation data so that they can get a realistic experience of working with the production app. Lots of context about your production environment just isn't available in dev. And having to hard code in all the rules saying oh, well, this table's big and that table, whatever, too much, too brittle. You'd be trying to, it's like a constantly shifting goalpost, whatever, building foundations on sand. So we went a step further even than doing the linting. And we went for runtime checks. And this is, I think, the gold standard for doing this. Because the only time you're going to have full context, the only place you ever know what your production environment looks like is in production. I don't really believe in staging environments. I think staging environments, we get back to the problem of a constantly shifting goalpost. It's hard to make them look real, and the best place to know what production is production. So if we insert ourselves into the migration process in production, then we have access to the production database. We have access to all of everything we need to know to make a guess as to whether the migration that's happening is safe. So we can kind of start simple and think about what unsafe operations are there. Mistakes can happen, like we said before. We're just talking about what's safe in dev isn't necessarily safe in production. I guess, yeah, risks are even greater now. I think I mentioned this earlier. Risks are even greater now with LLMs doing the driving. So we've had a couple of cases where LLMs are generating migration files, and they're not running the generator, and the migration file that comes out at the end isn't necessarily super well formed. So we wanted to handle cases like that. And one of the things we did, I lost Fred there a little bit, but yeah, we have this, okay, yeah, now I remember. So one of the things we did before we get into the really low-level stuff is we just overrode in our rake file the DB namespace, and we blocked DB reset, DB drop, things like that. We don't want anyone to drop the database in production, so there's no need to be able to run that rake task. We don't want anyone to reset the database in production. Another thing we did, this kind of harks back to the checklist from earlier, we don't want you to run db migrate, just the bare version of db migrate, because that will run every pending migration. And that's fine when you're one dev, two devs, a small team. But we sometimes have 10 migration PRs landing within 15 minutes of each other from different teams. We don't want them all running. Some of them might be for those massive tables. Another one might just be a create table for something that's being spiked out. So we want everyone to be deliberate about only running their own changes. So we force you to use the db migrate up and specify a version. So I hope you're never going to need to worry about these things yourself. But if you do, you can just grab that code snippet. It's right here. Drop it into your rake file. It should work. But we want to go further. We want to start building up some idea of what real migrations are safe. And we can do that. So our checklist used to tell teams that if they're migrating a large table, come and talk to my team. But that just introduces like one of those decision points like I was talking about before, one of these cases where you're choosing your own adventure, because now you have to know, like, is a table large? And like, at what point is a table large? That's not very clear. And we found that like what tended to happen was people became, either they knew they were creating a table, and that's fine, or they would just be uncertain, and they would want to come through us for every migration and like sense check it with us. Was it OK to run it? And like that's such a productivity drain, because there's only so many people on the team. We're only able to respond so quickly. When you want to run one of those big migrations, there are tools like Ghost. If you've seen Ghost, it's GitHub Online Schema Transformer, I think it stands for. Or there's like PT Online Schema Change, or Large Hadron Migrator. I think that's the Facebook one. There's a lot of different tools. But you have to learn how they work, and you have to know all of these command line switches. And again, we're deviating really far from the standard Rails flow at that point. Like we said, it's hard to use a tool like that. We're kind of breaking the just be normal principle I talked about earlier. We want to just run migrations with Rake. I guess you could package up running one of those tools with Rake. I wouldn't personally feel super safe doing that, but that's my risk tolerance in our production environment. Like, your mileage may vary. So one of the things we do to make sure that people don't have to ask those questions is actually just analyze the migrations at runtime. So we monkey patched active record migration, exec migration, which, if you know how internals work, like this is effectively the thing that calls the up method in your migration, or calls the change method. We used the active record command recorder, which is a nice bit of tech. If you've ever wondered how Rails can take your change method and work out how to reverse it without you specifying the reverse, it's thanks to command recorder, where it like executes the migration in a kind of dry run environment, works out the commands, and then it knows how to map every command to the reversed version of it. So running your migration in a dry run environment, getting the commands out, that's you might see where we're going here. And then we implemented our heuristics that we were using, like, if you came to me or any of my teammates, they're all sitting at the front here, if you came to one of us and asked, like, do you need to run this migration with Ghost? Did you need us to run it for you? We just like coded up those rules. And if you're going to hit something there, if you need to talk to us, we just raise and block the migration. We'll tell you, like, OK, no, this one, you need to come and talk to us. We'll post it in your console output. We'll post it into our Slack channel to say that someone just ran the migration and they're going to need some help. And yeah, that works pretty well. So again, I had to squeeze it onto the page a bit, but commands here is the internal of a command recorder, so it's like a list of operations. We block execute, and now we get back into why we blocked execute, because the command recorder doesn't actually know what you're doing in an execute. It just knows that one happened, so we don't want to deal with that. So we block you using execute in case you bypassed the Rubocop rule from earlier. And then we check, like, is the row count above a limit? And is the store size above a limit? And the reason we do that is we found, like, if tables are sufficiently long, like if they have sufficiently many rows, that can be a problem. But a small table with a lot of, like, very big rows, like a very wide table, that can also be a problem. So for us, these limits are 5 million rows or 5 gigabytes of data, which is, to me, low. Like, maybe my brain is broken at this point. 5 million rows sounds like an absolutely microscopic table to me, but I deal a lot with like 50 billion, so yeah. But that means that, like, if you're dealing with a new table, like you're building out a new feature, you're spiking it, you don't have to worry about this. We'll try and just get out of your way. But by the time you have 5 million rows, it probably has enough traction that doing something to it, locking it for some reason, might be an issue. And then we print out some nice formatted error message saying, like, hey, it's too big, you need to come talk to us. And the way we get the rows, we can't run select count star, because that would also be very slow. So instead we do explain select count star. InnoDB will give you a guess at how big the table is, and that guess is good enough for our purposes. Or we check the information schema to figure out how big is the table. We actually factor in the index size when doing that. I've never been completely certain if we need to, but we just do it anyway. We'll come back. You'll get a link to the code, so I'm skipping over it a bit fast for time. Another thing is, like, in older versions of MySQL, and until relatively recently, we were on 5.7, which was still affected by this. Dropping a big table wasn't safe. It wasn't safe because if the table was in the buffer pool cache, dropping it would synchronously God, I'm completely blanking on the word. It would synchronously like flush it out of the cache, and while it was flushing, the whole database could be locked. So we never wanted that to happen. So if we ever saw that the command being executed in a migration was a drop table, instead we would just rename the table to something else with a predictable format, and then we had another like periodic task that comes along and cleans up those tables. We don't worry if the table is smaller than 2,000 rows. We don't really mind what people do with that, with those little tables. So this is just another thing that now people can drop a table. They don't need to know what's happening under the hood. We just handle the rest of it. We also block change column. That might seem a little strange. If you change a column from like int to big int, fine. If you change a column from like string to text, fine. Those are all things that are normal and you might want to do. But if you change the column from int to string, or from, I don't know, some other type, two types that aren't compatible with each other, during our deployment process, you would have a bunch of processes that still know about the old schema. They have it cached. You have a bunch of processes that know about the new schema. Lots of breakages could happen. So we just ban doing change column. We go for like an expand contract model, where you add a new column, populate it from the old column, then drop the first column again, rather than changing it in place. It's a little tiresome, but there isn't really a better solution for making that safe. We also, just to have it's not included here, we include an escape hatch for like expert operators, my team, or some engineers, to just like bypass these checks, because again, you don't want to like take away the sharp tools. You want to make sure that like people aren't just juggling knives or whatever, but it is useful to be able to do them. So we do let you bypass this, but we run all of these checks and more in production on every change. And you can too, if you want to take a look at the code. This is probably the biggest single chunk of code, so there's a lot to go through. I would take it as a jumping off point. Like I said at the beginning, you don't want to just blindly take every idea. I'm not here to peddle the Google SRE book and tell you how to run your startup, but like there are ideas in there that I think are generally useful. And this is like literally the code straight out of our monolith, so feel free to take a look. That's kind of bringing me to the end. Like, where do we go in the future? Intercom is currently in the process of moving everything to planet scale, away from Aurora RDS in AWS. That does change a lot of the dynamics here, and it was part of why I wanted to talk about this, because a lot of these things are probably going to go away from our monolith, and I think they are kind of useful. We've already seen like a big decrease in issues that engineers were having, both with like shipping things and in production, since we implemented this for ourselves, and now moving on to planet scale, it's kind of changing things again. There's a different workflow. We've actually packaged up behind DB migrate again. We still are trying to stick to that just be normal principle, but that maybe will change. Planet scale has a nice flow that's kind of like a pull request for changing the schema, and maybe it makes sense to expose that to everyone. The dust is kind of still settling there, so we'll see. One thing we have got as a result of moving to planet scale is now we never have to tell engineers, like, hey, you have to wait for data stores on call to run your ghost migration for you, because that can just be handled under the hood by the planet scale workflow. So that's nice. But yeah, thanks very much. This is a link for like everything that's been in the presentation, so you can pull it down. Feel free to have a look. I'd love to talk about migrations and running big databases with anyone. And otherwise, I'll leave it there. So thanks.